Hello, this is Mr. Blagg, and I'm going to discuss function transformations today. Okay, and in fact, we're just going to discuss it with regards to a single point and how that point on some function, okay, transforms or moves after the transformation. So if I have some point 2 comma 3, okay, and it's on some function f of x, I don't know what that function looks like. Okay, I want to determine what the coordinates of this point will become after each of these transformations we see here. Okay, so this first one, okay, in part A, says y, or our new function, okay, our y, our transform function, is going to be 2 times f of x. Okay, when we see f of x right here, and then we see 2 out here, we're multiplying the whole function by 2. Okay, that actually changes the amplitude on the graph, but we'll discuss that more. I want to say that that's kind of like a transformation that's happening to the outside of the function, as opposed to a transformation happening to the x inside. Okay, so if we look at this, 2 times f of x, well, f of x, or the function value, is our y values. So we're going to take our y value of 3, we're going to multiply it times 2. So I should get 6. So my new point after the transformation, if we're transforming this function as we would in part A, would be 2 comma 6. Let's take a look at the next one. It says f of x plus 1. Okay, so I'm taking my function values, my y values, and I'm adding 1 to them. So for a y value of 3, adding 1 would become 4. Okay, we didn't adjust the x value, so it would still be 2 comma 4. Okay? And this whole process is called pointwise transformations of graphs. Okay, in this case, we're just doing a single point. Okay, let's take a look at C. It appears we're taking our function f of x, whatever it might be, and all the y values get negated. Okay, so that would be 3. Y is 3, right? And we're going to negate it. It's going to be negative 3. Okay, so I should have a new point at 2 comma negative 3. Okay, let's take a look at this next one. F of 3 times x. So apparently what's happening now is we're transforming and messing with the inside, quote unquote, okay, not an official term, of this function. So if we mess with the inside, okay, the inside is a liar. Let's just put it that way. So it does kind of the opposite of what we would see it to do. So we're not actually going to multiply the x values by 3, okay? We're going to multiply them by 1/3, okay? So we're going to go ahead and say x, okay, times 1/3, which is what? It's going to be 2 times 1/3, which gets me 2/3. My y value wasn't changed, so I'm going to say my new point after the transformation would go from 2 comma 3 to 2/3 comma 3. If you look at this next one, in E, it appears we're working on the inside of this function again, transforming the inside, and we're negating the x values. For this particular one, you're still going to do that. You're still going to negate, even though it's on the inside. There's nothing opposite. There's no other way to do something opposite of negating but to negate. Okay, so we're just going to take our x value and negate it. Well, what is negative, or what is 2 made negative? Well, it's negative 2. Okay, so we're going to get negative 2 comma 3. Let's continue. For part F, it says f of x minus 1. This is also happening on the inside. Okay. So what I see here, I actually want to do the opposite. So rather than take x and subtract 1, I'm actually going to be adding 1 to all my x values. So that means that my new x value should be 3. Okay. And we'll still have the same y value of 3. I think you see what we're doing here. So I want you to go ahead and pause the video and try the example G and H. And then when I come back, or when you come back, I will have answers for you up on the board. So go ahead and pause the video and try those now. Remember to ask yourself whether this transformation is happening kind of on the inside or the outside. Okay? And to remember that if it's happening on the inside, we have to do the opposite of what we see. So for G, I would say that the answer is 0 comma 3. For H, I would say the answer is 2 comma 0. Okay. And we will discuss transformations in more detail in class, not only transforming single points, but entire sets of points for a function, and not only transforming them point-wise, but we'll actually do what's called figure-wise, where we'll be able to qualitatively transform a function without having to make, do it point by point by point by point. Okay? And so we'll get there. All right, so we'll see you next time.